Chemical formulas, nomenclature. So a molecular ion is an atom with a charge. We already know that cation is a positive charge and anion is a negative charge. We also know that cations, or positive charges, are our metals, and anions would be our nonmetals because they form the negative charges. So to name a cation, you simply copy the name off of the periodic table. To name an anion, you change the ending to IDE. So when you see the ending of a name IDE, then you should know it comes from the periodic table. So for example, Na+, the positive is telling us that that is a cation, so we're just going to copy the name off the periodic table, sodium. Now because it's got the charge there, we need to indicate that in the name, so we write the word ion. Chloride, IDE is telling me it comes off the periodic table, so it's the element chlorine. The IDE also tells me that it's a negative charged ion. So chlorine in group 17 forms a -1. Now you could write that as Cl1-, or because it's a charge of 1, you could just write minus. Binary ionic. Binary means that there are two elements. Specifically for ionic, that means you have a metal and a nonmetal. So you write the cation first, and then you write the anion, changing the ending to IDE. When you write a formula, you need to make sure that you cross your charges. So for example, the first capital letter is always your cation. Na is sodium. Cl, the second capital, is always your anion. So Cl would be chloride. So NaCl is sodium chloride. Mg is magnesium. And F would be fluoride. The fact that there's a subscript 2 there doesn't matter. Here we have names, so we want to cross our charges to write our formula. So calcium is Ca+2. Nitride, IDE, off the periodic table would be nitrogen. Nitrogen is -3. So we're going to cross the number down. Cross the number down. The positive and negative go away because it's a neutral compound when you put a positive and negative together. So we get Ca3N2. Aluminum sulfide. Aluminum is Al+3 because it's in group 13. Sulfide, sulfur off of the periodic table is a -2. So we're going to take our number, cross it down. Take the number, cross it down. Positive and negative goes away because now it's a neutral compound. Al2S3. If it contains more than one capital letter, then it's a polyatomic. All of your polyatomics are listed on page 224, and they're in the reference table, so you don't have to memorize them. You give the cation, then you name the anion. If it's a polyatomic, you don't change the ending. So the only time you change the ending is if it's a nonmetal from the periodic table. For example, we have Ca and then we have OH in parentheses. The OH in parentheses tells me that that's a polyatomic. So this is calcium hydroxide. In letter B, I have 3 capital letters, so I have to have a polyatomic. The choices would be Na2C or CO3. So looking on page 224, I can match it up to CO3. So I'm going to put that in parentheses. Na would be sodium. CO3 would be carbonate. AgNO3. Again, it can either be AgN or NO3. On page 224, NO3 is the polyatomic. So this would be silver nitrate. Here I have 4 capital letters. So I have one polyatomic in parentheses here. PO4 must be another polyatomic. So this is ammonium phosphate. I'm just copying the names from page 224. Here we have names, so I would want the formulas. So we want to make sure that we cross charges. So barium in group 2 is +2. Hydroxide is a polyatomic that contains hydrogen and oxygen. It's one of the only polyatomics that ends in IDE. So if we cross our charges to the outside of the parentheses, we have BaOH2. Ammonium is our only cation polyatomic, NH4 + 1. Nitrate, the ATE is telling me that it's a polyatomic, NO3 - 1. So when I cross my charges, I would have NH4 NO3. I don't need parentheses anymore because I only have one of each of those. Calcium nitrite. Calcium is Ca + 2. ITE is telling me it's a polyatomic, NO2 - 1. Cross to the outside of the parentheses, Ca NO2 2. Transition metals or post-transition metals. Remember, transition metals are in the D block, groups 3 through 12. Post-transition metals are any metals found under the stairs except aluminum. We have to show the Roman numeral for the charge. If you don't know your Roman numerals, you do need to know those. 1, 2, 3. 1 before 5 is 4, 5. 1 after 5 is 6. 2 after 5 is 7. 3 after 5 is 8. 1 before 10 is 9, and then 10. So you're going to use the Roman numeral to indicate the charge on the metal. So you give the name of the cation and the Roman numeral to represent the charge. Then you name the anion. So for example, tin 4. So the charge on tin is 4. It's a +4 because tin is a metal. Iodide, IDE, it's an element on the periodic table. Cross the charges, SN, I4. Iron 2, the 2 belongs to the iron as the charge. Sulfide, an element on the periodic table. So Fe + 2, S - 2. That would give us Fe2S2. Well, 2 and 2 can be reduced, so the actual answer is just FeS. Copper 2 sulfate. The 2 belongs to the copper. The ATE tells me that it's a polyatomic. So I have Cu + 2 and then SO4 - 2. So that would give me Cu2, SO4 2. 2 and 2 reduces to CuSO4. Vanadium 3. The 3 belongs to the vanadium. So V + 3, Br - 1. Cross the numbers down. V, Br 3. Here we have formulas and we'll need to name them. So the first thing we want to do is uncross our charges and check the negative. Sulfur does form a -2 charge, so this has not been reduced. So we would say iron 3 sulfide. There's a 1 here that's understood. So if I uncross my charges, the negative is correct for chlorine, so this is not reduced, and it's just copper 2 chloride. Uncross your charges, -1 + 3. -1 is correct for bromine. So this is copper 3 bromide. If I uncross my charges, I get a +2 and a -1. But oxygen is supposed to be a -2. So I'm going to multiply by 2, multiply by 2. So this is actually tin 4 oxide.